everybody. My name is Sonja Swanson. I'm an assistant professor at the Department of Epidemiology at Erasmus Medical Center. On behalf of my co-authors, I'm thrilled to have this opportunity to describe our article on the analogy between Mendelian randomization studies and randomized trials. So first, a little bit of background on Mendelian randomization. This is a method or a set of techniques based on the premise that we can leverage our genetic variants as a sort of natural experiment. So for example, if we're interested in studying the effects of obesity on depression, we can use obesity-related genetic variants as sort of a naturally occurring randomized trial to study this effect. And indeed, this analogy between a trial and Mendelian randomization designs is an incredibly seductive and powerful idea. What we sought to do in our paper is to really think deeply about what this analogy means for the implications to how we design, how we conduct, how we report on and interpret Mendelian randomization studies. So just as one example of this, one consequence of thinking about this analogy is that the way that we would validly estimate effects in a randomized trial should have analogs to how we would do it in a Mendelian randomization design. So one thing that we consider is what the analog is of the intention to treat effect in a Mendelian randomization study. And as we consider this effect in depth, we realize that there's a couple of fundamental differences between the design that occurs in common Mendelian randomization approaches and those in randomized trials. One example of this is that the concept of time zero is unclear in a Mendelian randomization study. In a randomized trial, we set our eligibility criteria, we randomly assign our treatment strategies, and we begin recording outcomes all at a unified time. Meanwhile, in a Mendelian randomization study, these often are misaligned. Our genetic variants, which are the analog of random assignment, are inherited at conception, but sometimes eligibility criteria and the recording of outcomes actually occurs decades later in life. And we know in randomized trials that doing any sort of post-randomization restrictions can cause bias in our effect estimates. Indeed, this raises concerns for Mendelian randomization studies as well. We also note in our paper that the concepts or the analogs of adherence and the per protocol effect are relatively unclear in Mendelian randomization studies. One point that is clear, however, is that the typical analysis conducted in a Mendelian randomization study is what would perhaps be appropriate in analogous randomized trial for a one-time treatment or a time-fixed or point intervention, so something like a one-time surgery. On the other hand, the common exposures or treatments of interest in a Mendelian randomization study can vary over the entire life course, so they're more analogous to a sustained treatment strategy. And I encourage you to read our paper to learn why this discrepancy is important and what the implications of it are to valid interpretations of Mendelian randomization studies. So altogether, deconstructing this analogy provides some insights into the strengths and limitations of Mendelian randomization studies, as well as a perspective on future methods developments or interpretation of the numeric results. At the end of the day, as we also conclude in our paper, I see this as not a simple strength of the Mendelian randomization study, but rather a complex and helpful framework for both improving and understanding the validity of our Mendelian randomization research. And with that, thank you so much for joining me, and I really hope you enjoy reading our paper.